talking about angles of triangles. So the first thing we're going to talk about is actually something we touched on a little bit yesterday, and today we're just going to talk about its name, and that is the triangle angle sum theorem. And your key words here are that it is going to be the angle sum. So we want to add up the angles of a triangle. Okay? So on here we have three angles, angle A, angle B, and angle C. And we know that if we add up these three angles, that no matter what size triangle we get, it will always have all three of its angles add up to 180 degrees. So that's not very pretty, 180. Okay? And so this number here, 180 degrees, is really important. And we talked about and practiced a little bit yesterday, and we'll practice a little bit more tomorrow, but we talked about that if you do this, they could give you, the measurements of two of those angles, and you could solve for the third one. We talked about if they gave you algebraic expressions, you could plug those in for each of the angles, and you would be able to find out what each of the angles and or a variable is. And so all of that is made possible by this theorem. And so you just need to know that this is the name of the theorem, because if we have to do a proof, and you have to be able to do this in the proof, then you have to have a reason, and your reason would be the triangle angle sum theorem. Okay? Another thing that we're going to use a little bit is called an auxiliary line. So, for example, if we have a triangle like this, and we need to be able to talk about angles, okay, we might need to draw an extra line or sometimes an extra two lines here, and these are going to be what are called auxiliary lines. And so an auxiliary line is going to be an extra line or line segment that we draw on there that helps us analyze different relationships. Okay? And so, for example, we might be able to use this angle here. Maybe they give us this one and tell us it's 70 degrees. And we might be able to use these auxiliary lines then to say, hey, I noticed that then these angles here would have to be their alternate interior angles. They would have to be the same. And so I would know that this whole angle up here would be 70 degrees. And I might be able to use that to help me find whatever they're asking for in the problem. So we'll look at some specific examples in class of where this might be helpful. But what you need to know is that you can draw a line anywhere you want to, an extra one. It will be called an auxiliary line. And sometimes they're really helpful and sometimes they're not. Sometimes you draw them and you go, that didn't really help me out. And other times you draw them and go, wow, that really gives me some extra information. So again, we'll look at those a little bit in class tomorrow and go through a couple of specific examples tomorrow in class as well. Okay. Next, we're going to look at some exterior angles. So this is what's going to be called an exterior angle. We have this angle outside of the triangle. It's formed by one side of the triangle being extended and another side of the triangle, but it's an angle that is on the outside of the triangle. Okay, so exterior still means outside. Then you're also going to notice that we still have three interior triangles. Angles 1, 2, and 3 are all interior triangles. And so we have a theorem that's going to help us find the measurement of this exterior angle, angle 4. Okay? And so what that theorem is going to say is that if you add up two remote interior angles, it will give you that one exterior angles measurement. Okay? So these two have to be remote interior angles. So let's talk about what that means. So an interior angle is obviously on the inside of the triangle, so that narrows it down to either angle 1, 2, or 3. And remote means far away, kind of like your remote control for your TV helps you control the volume or the channel setting from far away. That's why it's called a remote control, because you can do it from far away. Or you might have heard that somebody went to a remote location, meaning they went far away from everybody else. Same thing's going to apply here. So we're looking for the two angles that are farthest away from the exterior angle we're interested in. So since angle 4 is the exterior angle we're interested in, right, so that's going to be exterior angle number 4, then the two angles that are remote and interior are angles 1 and 3. Okay? Angle 2 is also an interior angle, but it is right here, right next to angle 4. They're almost next door neighbors, right? So angle 2 is not a remote interior angle. It's just interior. So we would add up the measurement of angle 1 and the measurement of angle 3, and those two angles added together would give us the measurement of angle 4. Okay, and that would help us find that out. And that is called the exterior angle theorem. Okay. Finally, we have two corollaries, and they're called triangle sum corollaries. And corollaries come from proofs, and they're basically, if you use a proof to show that one theorem works, and you come up with another theorem, that's what a corollary is. So as far as we're concerned, a corollary is just another rule, all right? And so we can use these in our proofs that come. And so our first one here is the acute angles of a right triangle are complementary. So what they're saying is if you have your right triangle, okay, and you add up these two acute angles, so you add up the two angles that are not the right angle, those two angles have to add up to be 90 degrees. Okay, so if I add up, let's call this A, B, C. So if I were to add up angle B plus angle C, those have to equal 90 degrees. And if you think about it a little bit, it really makes sense because all three angles have to add up to 180. You already have this right angle over here takes care of 90 degrees out of that 180. And so all that's left is 90 degrees. And sometimes that's just really helpful to shorten things up when we're dealing with a proof. Our second corollary is that there can be at most, meaning no more than, one right or one obtuse angle in a triangle. So we talked about this a little bit yesterday, but if you have a right triangle, it will have one right angle. It can't have any more than that. And if you have an obtuse triangle, it will have one obtuse angle, no more than that, okay? And those, again, stem from the fact that all the angles of a triangle have to add up to 180, and so it wouldn't be possible to have two right angles. Those would add to 180, and there'd be nothing left for the third angle. And same thing with the obtuse angles. You couldn't have two angles that were larger than 90, or all three angles would have to add up to more than 180, so you wouldn't have a triangle. So I look forward to seeing you in class tomorrow. Thank you for watching, and I hope you have a lovely afternoon. Goodbye.